Hello everyone. Previously we have learned how to expand the product of two linear algebraic expression using this law that what we call distributive law of multiplication. Sometimes you may refer it to as the rainbow method. That is, so I'm going to zoom in now, that A times bracket B plus C, right? When we do the expansion, we are literally multiplying this. A times B will be AB. A times positive C, both positive, so it will be plus AC. Or, this will be AB. A times negative C will be negative AC. Yep. And some things to take note of before we move on to the examples is that 2 times AB is equal to 2AB. It does not equal to 2A times 2B. Okay, this is important. 2 times A minus over B is equal to, this is important to take note, that it is actually equals to 2 over 1. Times A over B, and therefore this will be equals to 2A over B. 1 times B is B. Okay, it does not equals to 2A over 2B. Okay, and bearing that in mind, let's look at 3 examples here. So this is just a quick example. So from here, we will then be able to equals to 2 times 5 is 10. M times A is MA or AM. 2 times 3 is positive 6. M times B is BM or MB. And we are good. Continue the next example. Negative 3x times positive 4x will give me negative 12x. Negative 3x times negative 2y. Negative times negative will give me positive, in this case 6xy. And we are done. And the last example that involves this simply means that we are going to have 4 multiplied by 9. Both are positive, so it's 36. 4 multiplied by negative 2h, negative 8h, negative h, multiplied by positive 9, negative 9h, negative h, multiplied by negative 2h, negative times negative, positive 2h square. This is not the final answer because I do see that there are like terms for me to continue to simplify. So you will see 36, negative 8h and negative 9h. They will make negative 17h. And there is the positive 2h square. And we are done. Important note to take note is that h and h square are unlike terms. So we do not simplify them further, okay? Because we cannot simplify them further, okay? They are unlike terms, unlike terms. We only simplify the like terms. They are unlike terms, okay? And with that, we have come to the end of this very quick recap of how to do distributive law of multiplication on algebraic expressions. Right, hello everyone, welcome to this video where we have this special products of algebraic expression, and we are going to try out each special products, which you may consider them to be like a formula. So for the first one, where we have a plus b bracket square, this simply means that we are actually multiplying a plus b by a plus b. So if I were to write it down here using the multiplication frame, it will be positive a, positive b, positive a, and positive b. And I'm going to multiply them together. Meaning a times a is a square, a times b is ab, a times b again is ab, b times b is b square. And if I were to use the distributive law of multiplication, where I will have a times a, they will give me the same answer. Multiply a times b, multiply, I will have positive ab, positive b times a, and a times b is the same. And I would have positive b square, and eventually the a, b are like terms, and I would have this identity or formula that we could use if we see a plus b bracket square. We can just substitute into this formula. Alright, so let us look at another special products, a minus b bracket square. Again, it is a minus b times a minus b. So if I were to use the distributive law of multiplication, I multiply, I will get a square. Positive a times negative b will give me negative ab. Negative b times positive a will give me negative ab again, and negative b times negative b will give me positive b square. And after I simplify the like term, negative 1ab minus 1ab, there will be 2, negative 2ab, and positive b square at the side. If I were to use the multiplication frame, I will have a and negative b here, a and negative b here, and when I multiply them, I will get back the same answer. A times a is a square, a times negative b is negative ab, a negative b times a is negative ab, negative b times negative b is positive b square. And so that will be the formula or identity for a minus b bracket square. As I move on to the third and last special product. Now, this is really special because it is no longer a plus b bracket square or a minus b bracket square. It is a plus b times a minus b, and let's see what will happen, okay? A times a will be a square. A times negative b is negative ab. Positive b times positive a, positive ab. Positive b times negative b, negative b square. And notice what happened. Negative ab plus ab, this one will become, yes, this will become 0. So when it is 0, we don't have to write it anymore. And we actually get this special product. So I'm going to make one of the too many equal sign already, okay? So this one I'm going to just make it into one equal sign. Alright? So that will be the last part, and if I were to use the multiplication frame, I would also get back the same answer. If I have a plus b, which is positive b, a and negative b, and when I multiply them, I will get a square. This is positive ab, this is negative ab, and this is negative b squared. And we actually have three different identity. A plus b bracket square is equals to a square plus 2ab plus b square. A minus b square is equals to a square minus 2ab plus b square. And strangely enough, a plus b times a minus b is equals to a square minus b square. And sometimes the textbooks or the notes of the assessment books refer them to difference, do take note of the typo error, of two squares. And the last part is a misconception that students actually thought that a plus b square is equal to a square plus b square. So do take note, they are not equal. Not equal. And how do we prove that? This is the proof. Example, if we put 3 plus 4 bracket square, 3 plus 4 is 7. 3 plus 4 is 7, and 7 square is 49. But if I do 3 square plus 4 square, 3 square is 9, 4 square is 16. I add them out, it's 25. And these two are not equal to each other. Alright? So using the same logic, a square minus b square is also not equals to a square minus b square. And if you want more example, I could do the same as well. I could have, for example, two plus 1, 2 minus 1 bracket square is equals to 2 minus 1 is 1. So 1 square equals to 1 times 1 is 1. Then, but 2 square minus 1 square. 2 times 2 is 4. 1 times 1 is 1. This one is actually equals to 3. So 1 and 3, they are again not equal. Okay? So please remember, a square, a plus b bracket square does not equal to a square plus b square. Similarly, a minus b bracket square does not equal to a square minus b square. With that, we have come to the end of this video. If you like this video, do give it a thumbs up. Thank you for watching. Have a nice day. Everyone, welcome to this video where we are required to expand and simplify using the special products. So I see a plus, I'm going to choose the plus, which is this. Okay, so my y becomes my a. So notice what I'm going to do. My y, that will become my a. So this one will be my y square plus 2ab. Okay, so I just need to substitute into this formula, and you will actually straight away very quickly get what is required. Okay, so this one final answer, y square is y square plus 2 times 4 is 8, so it's 8y. 4 square is 4 times 4, 16. And we are done with this example. Hello everyone, for this particular question, we are required to use the special product to solve this question. I see a plus, I'm going to go to the plus formula. And the first thing is, this will be my A. So notice later, I will substitute all the A with 2n. This will be my B. I will substitute all the B with 5. And therefore, this is what you should see later on. So this one will be equals to my A square plus 2 times my A times my B, and plus my B square. After that, continue to simplify. 2n square is 2n times 2n, so it's 2 times 2, 4, n times n square. So from here also 2 times 2 is 4, 4 times 5 is 20. Still got my n down there. 5 square is 5 times 5, 25, and we are done with this question. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day. Hello everyone, welcome to this video where we are required to expand and simplify this using the special product. So of course the first thing is to choose the out of these three, choose the correct one. I see a plus, I'm going to choose the A plus B bracket square special product, and this will be my A. So later you will see me substituting all the A with 3x. And this will be my B. And you will also see me substituting all the B with 2y. And without further ado, this will be the solution. 3x. This is my square plus my 2. A now is 3x. B now is 2y. And my C, no C, but a B square, so it's 2y square. After which I continue to simplify. 3x square is 3 times 3, 9, x times x, x power 2, plus 2 times 3 is 6, 6 times 2 is 12. Still got my x and y. 2y square is 2y times 2y, 2 times 2, 4, y times y, y square. And there's no more like terms. This will be the final answer. Thank you for watching and have a nice day. Hello everyone, welcome to this video where we are required to use the special product to solve this problem, and step 1, I need to choose the correct product to use, which is in this case A plus B bracket square. And once I choose that already, I need to know which one is my A. In this case is 1, and which one is my B, the whole n square. Okay, so later you will see me substituting B with n square, and this is what you should see. Okay, so my A is 1 square plus 2 A. B is n square. Okay, plus my b square. Once I finish substituting into the correct special product, I continue to simplify. 1 square is 1 times 1, 1. 2 times 1, 2. Still got my n square. And n squared square. Okay, for those who are not very good at that, n square square is equals to n square times n square. So how many n are there? Yep, there are 4. So n to the power of 4. And there are no more like terms. This will be the final answer. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day. Everyone, welcome to this video where we are required to use a special products to expand and simplify this term. I must first choose the correct special product. I see a minus, c minus 2 bracket square, so I'm going to choose the a minus b bracket square. And later on, you will see that I will substitute all the a with my letter c, and b with my number 2. And therefore, this will be the a square, so it's c in this case, minus 2 a b. b is 2 in this question, plus my b square, which is 2 square. And continue to simplify. C square is c times c square. Then I will have 2 times 2. Notice there's a minus, so it's minus 4. And still got my c, okay? Plus 2 square is 2 times 2, 4. And there's no more like terms after this. We have come to the end of this video. If you like this video, do give it a thumbs up. Thank you for watching. Have a nice day. Hello everyone, welcome to this video where we are required to expand and simplify using special products. The very first thing is, do take note for this question. I'm going to focus on my second negative sign. And therefore, I will choose the a minus b bracket square. Meaning, negative 4e will be my a, and 3 will be my b. And therefore, this one will be equals to negative 4e bracket square minus my 2a, in this case is negative 4e, b is 3, plus my b square. Square. Once I've substituted the correct a and b into the correct special products, I'm going to simplify. So negative 4e square is negative 4 times negative 4, positive 16, e times e is e square, and negative 2 times negative 4 is positive 8 times 3 is 24, positive 24 e, and the last is 3 square is 3 times 3, 9. There are no more like terms. We have come to the end of this video. If you like this video, do give it a thumbs up. Thank you for watching and have a nice day. Hello everyone, welcome to this video where we are required to expand and simplify using special products of algebraic expression. The first thing you must do is to choose the correct special product. In this case, I choose the minus a minus b bracket square. And later on, you will then see me substituting the A with 7p, B with 4q. And this will be equals to 7p bracket square minus my 2a b plus my b square 4q square. And after which, continue to simplify. 7p square is 7 square. 7 times 7, 49. P square is p times p. P square. And after which, 2 times 7 times 4, negative. Do take note. So this will be equals to negative 56. P times q is pq. And 4q square is 4 times 4, 16. Q times q, q square. And there are no more like terms. We have come to the end of this video. If you like this video, do give it a thumbs up. Thank you for watching. Have a nice day. Hello everyone, welcome to this video where we are required to expand and simplify using the special products of algebraic expression, and I see a minus. You must choose the correct algebraic special products, okay? And therefore later on you will see me substituting my a cubed with a and my b with b. So without further ado, you will then see me writing my a power 3 square minus my 2a b plus my b square. And after which, you can then see that a power 3 square is a power 3 times a power 3. So at the side, you will then see me writing a power 3 square is a power 3 times a power 3. So how many a's are there? Yep, there are 6 of them. So this one will become a power 6 minus 2a power 3b plus my b square. And there are no more like terms anymore. This is the final answer. Thank you for watching and have a nice day. Hello everyone, welcome to this video where we are required to use these special products to expand and simplify. And notice, you must select or choose the correct special product. So in this case, right, I see that I'm going to go with this a plus b times a minus b because I do see this as the correct one. And later on, you will then see me substituting my a as b and my 3 as my b. Follow the color coding, and therefore this will be the answer. This will be equals to a square minus b square, right? So this one will be equals to b square minus my 3 square. B times b is b square, 3 times 3 is 9, and we are done. Alright, so do take note, we just need to apply the special product and substitute the correct values or terms correctly. We have come to the end of this video. If you like this video, do give it a thumbs up. Thank you for watching. Have a nice day. Hello everyone, welcome to this video where we are required to expand and simplify the following using special products, and we actually have to choose the correct special product. I see it, 1 minus 2q plus 1 plus 2q. I'm going to apply this special product, and later on you will then see me substituting my a as 1 and my b as 2q into the formula, where this will become a square minus b square. So straight away when you apply the formula, this will become 1 square minus 2q square. After which, just simplify. 1 square is 1 times 1, 1. 2q square is 2 times 2, 4q times q, q square, and we are done. Thank you for watching this video and have a nice day. Hello everyone, welcome to this video where we are required to expand and simplify the following using a special product, and we of course have to choose the correct special product. Okay, so we are going to use this because I see the special product in this form, meaning I saw a plus b, a minus b. 3x is my a, 4y is actually my b. And once I successfully identify the correct special product, right, I will just need to apply this special product, because I know the end result is a square minus b square. So you will then see me substituting my a as 3x. This is a square minus my b as 4y. Next thing would then just be to simplify it. 3x squared is 3 times 3, 9x times x, x squared. 4y squared is 4y times 4y, meaning 4 times 4, 16, y times y, y squared. And we have come to the end of this video. If you like this video, do give it a thumbs up. Thank you for watching and have a nice day. Hello everyone, welcome to this video where we are required to use a special product to expand and simplify the following. And first and foremost, we have to select the correct special product to make use of. And I noticed there's this pattern here. So I saw that a could be my negative 2a. So I'm going to substitute a as negative 2x later. And my y as my b. So you would then see me writing this down. My a square will be negative 2x bracket square minus my y, which is my b square. So negative 2x square is negative 2 times negative 2, 4x times x is x square, y square is y times y, y square. And we have come to the end of this video. If you like this video, do give it a thumbs up. Thank you for watching and have a nice day. Hello everyone, welcome to this question or example where we are required to expand and simplify each of the following products. So let's zoom in on the first example where we are given this. So I'm going to apply the expansion distributive law of multiplication. So I will have this x square multiplying by y square. They will give me x square y square. I will have them multiplying by 2x cubed positive 2 x power 5. Okay, because there are 5 of the x times x times x times x times x 5 times x power 5. Something to take note of, okay? Negative 3y multiplied by y squared, negative 3y cubed. Negative 3y multiplied by 2x cubed, negative 6. There's x cubed, there's y. And since there is no more like terms, this will be the final answer. Okay? Let's move on to part B. Again, applying the distributive law. This time round, there is the only complicated part or the difficulty level that has increased is that we are dealing with algebraic fractions. So just be mindful. When we multiply fraction, algebraic fractions or numeral fractions, the numerator multiplied by numerator, so in this case is my x squared multiplied by 2x, they will give me 2x cubed over 4 multiplied by 3, 12. Continue. And you will see that this will be x squared multiplied by negative, positive multiplied by negative. You will see me writing the fraction as negative. The numerator will be x squared y over 4 times 2 will be 8. Now is the other fraction that I'm going to multiply them to. So negative multiplied by positive, you will get a negative fraction. Again, it is the numerator multiplied by numerator. In this case, 4x over denominator multiplied by denominator, 15 y squared negative multiplied by negative will give me positive. Numerator multiplied by numerator, this will be 2y. Denominator multiplied by denominator, 10y squared. And from here, we are going to apply what we have learned about simplifying algebraic fractions. But before that, I do see that the very first term here, I can divide by 2, left 1, divide by 2, left 6. Okay? And I can also divide by 2, left 1 for this last term here, divide by 2, left 5. Okay? So now the next part here is then to combine into a single fraction for this whole list of expression, which I'm going to share with you how to do it. First of all, I'm going to draw a long line because I'm going to make them into a single fraction. I will need a common denominator. Okay? And looking at the numbers, 6, 8, 15, and 5, the LCM of 8, 6, 8, 15, 5 would be 120. Okay, so this means that also I also see that there is a y square down there. So I would need the y square as well. So once I have ascertained the lowest common multiple of 6, 8, 15, and 5, then I could then know what to multiply with to make them equivalent already. I will have to multiply by 20, multiplied by 20, so that, and also the y square, so that on top here would be 20 x cubed y square minus, I will have to multiply by 15 y square so that this one will become 15 x square y cubed minus, this one I will have to multiply by 8 to give me 32x, and the last one I will have to multiply by 24 to give me 24y. And that will be the answer for this particular question. Alright, and with that we have come to the end of this part of the video, and let's move on to the next part of the video. Hello everyone, welcome to this example here where we are required to simplify two expressions in part A and using the answer to A part 2 to find the value of this numeral expression. Okay, so let's work on part A part 1 and A part 2 first. So n square minus n minus 2, n plus 2. At this point, it is a very good habit or practice to write a square bracket for the n minus 2 times n plus 2, because when we expand and simplify, we actually expand and simplify this first. And this one I'm going to apply my previously what I've learned, we have learned also on if I have a plus b times a minus b, this is one of the special products. I will have a square minus b square. Okay, so in this case it will be n square minus 2 square. So I will have n square minus my n square minus 4. So continue to simplify, you will get minus n square. This is important. Negative times negative will give me my positive 4. And final answer, positive 4. Because n square minus n square is equals to 0. A part 2 is straightforward, because from here, just by pure observation, I would then be able to see that if you have successfully observed, I'm going to color code them now, okay? N 2a 2 and a. Do you see that? And therefore, if I know that this final answer is going to lead me to 2 times 2, 4. It comes from here. Therefore, here for part 2, I don't even need to do all the working. Straight away, a square. Done. Just by pure observation. And now we are going to make use of this result for part B. where I will have 16947 square minus 16944 multiplied by 16950. From here, I could see the similarity already. I know what number is my n already. 16947, 16,947. Which brings me to the point where when I write this down, I then need to write it in this form. 16947 minus some number 16947 plus that same number, and therefore this number here has to come back to this. So what number should I minus from 16,947 to give me 16,944? Yes, if I minus 3, I will get back my 16,944. And if I plus 3, this will give me 16,950. And so I have successfully found what is my number for A. And because I know that, right, it is equal to A square, right? So this one is simply equals to 3 square. So final answer, 9. And with that, we have come to the end of this example here. So if you like what you are seeing thus far, do remember to give the thumbs up and subscribe to my channel. Hello everyone, welcome to this video where we are going to expand the following products. Although there are 3 terms multiplying by 2 terms in each bracket, don't worry, we will just have to expand slowly but steadily, okay? So this is one way. We are going to multiply this. 2t squared multiplied by 3t, this will give me 2 times 3 is 6. T squared times t is t power 3. 2t squared multiplied by negative 2 will give me negative 4t squared. Negative 3t multiplied by 3t will give me negative 9t squared. Negative 3t multiplied by negative 2. Negative times negative will give me positive 6t. Last, positive 2 times positive 3t. Positive 6t. Positive 2 times negative 2, negative 4. Next step would then be to simplify any like terms that you see. There is no like terms other than 6t cubed. I do see a negative 4t squared and negative 9t squared, negative 13t squared. I also see positive 6t, positive 6t. They make positive 12t. Last but not least, negative 4. And this will be the answer for this question, part A. And then move on to here, same thing. 1 times negative 4w squared will be negative 4w squared continue to multiply. This will give me positive 1 and negative 3w. Negative times negative will give me positive. Here is 20w cubed. Negative times positive will give me negative. Negative times negative will give me positive. In this case, 15w squared. And let's continue to simplify any like terms that you see. Usually, I like to start with the terms that has the highest degree of power. So in this case, it's 20w cubed. Positive. No others. I see for the w square. I see a negative 4w square plus 15w square. This will give me positive 11w square. And I also see a negative 3w and negative 5w. This will give me negative 8w. And last will be my positive 1. And we are done with this example. Alright. So if you like this video, do give it a thumbs up and subscribe to my channel. Hello everyone, welcome to this question where we are going to expand and simplify the following. And if we do see cases where we could apply special product, it is recommended that we do so. So in this case here, we do see that for part A, we can apply for this particular bracket here. We could apply a minus b bracket square is equals to a square minus 2ab plus b square. And so for this particular question here, then this is what we are going to do. We will have my 2x square minus 2 times my 2x times 1 plus 1 square. And we are going to simplify that first. Then we'll have 4x squared minus 4x plus 1. And after which, it is essentially just applying the distributive law of multiplication, where we will have 12x cubed. And when I multiply them, this will give me negative 16x squared. I will have my negative 4x multiplied by positive 3x, negative 12x squared. And this will give me positive, negative times negative will be positive 16x. Also have this positive 3x and negative 4. Last but not least, to ensure that we continue to simplify any like terms, so here we will have 12x cubed. That's the only term for x cubed. Negative 16x squared and negative 12x squared, negative 28x squared. I also see a 16x plus 3x, 19x, and of course we still have a negative 4 at the back. And that will be the answer for this example. And as I move on here, Again, we just need to do it slow and steadily. So I'm going to, step 1 will be to expand and simplify these two first. So this will give me 2a cubed and positive 6a. I still need to multiply by 4 minus a. So now, continue the distributive law. I will have 8a cubed negative 2a power 4 positive 24a negative 6a square. And since there is no more like terms, this would then be the final answer for this particular example. And with that, we have come to the end of this video. So if you like this video, do give it a thumbs up and subscribe to my channel. Thank you for watching. Hello everyone, welcome to this work example where we are given a trapezium. And from here, we need to show that the area of this trapezium is equals to 16x power 4 minus 9. Now, we are given the parallel sides, and that will be very useful because, do take note, to find the area of a trapezium, we do need to find the sum of the parallel sides. So in this case, it's 3x squared plus 5x squared plus 6. Another piece of information that this question gives us is the height. How do I know it is a height? It is perpendicular. Yep. So therefore, I also have the important height here. So all we have to do is to apply the formula for the area of a trapezium. Okay, which I'm going to apply now. So area of this trapezium is therefore equals to half times the sum of the parallel lines. So I will have 3x squared plus 5x squared plus 6. I need to sum them out first. So I put a bracket multiplied by my height. And now this is the expression that we are going to work towards 2. So it will still be half outside. This will be 3x squared plus 5x squared will give me 8x squared plus 6. So I have my 4x squared minus 3. And at this time, right, this is a trick that or manipulation that I'm going to do. Okay. I am going to take out a common factor here for my 8x squared plus 6. I realize that 8 and 6 has a common factor of 2. So I'm going to take it out and I'm left with 4x squared plus 3. And when I do that, I could then start work already. So half times 2, this will give me 1. So I don't really need to write anything about it. So I'm actually eventually left with 4x squared plus 3 multiplied by 4x squared minus 3. And going back to this question here, then I start to see that the last part would then be for us to apply this formula. A plus B times A minus B, this special product is equals to A squared minus B squared. Okay? And so if I were to A and A I will have 4x squared. The whole 4x squared is my A. My B is my 3. So if I were to rewrite this, this will be equals to 4x squared, the whole thing, square, minus 3 square. By applying this. And after which, 4x squared is equals to 4 times 4, 16. X squared times x squared, x power 4. 3 times 3, 9. And this will be the answer that we have successfully shown that the area is indeed 16x power 4 minus 9. Okay, so as you can see, for this particular question, you do need to have knowledge of how to find the area of a trapezium. On top of that, you do need to have some knowledge about the special product of the algebraic expression, the expansion. Okay, with that, we have come to the end of this example. So if you like this video, do give it a thumbs up. Thank you for watching and have a nice day.